Good afternoon. Welcome to Biomass Engineering's webinar series. Today, our topic is financial benefit dust tight conveyors. My name is Tim Brown, and we will be discussing several topics today. We understand everyone's situation is a little bit different. So as we go through things, just try to think of ways how the items we discuss might apply to your situation. Thank you for joining us, and let's get started. Our topics today will be dust tight versus dust control. Just a brief explanation of that. Material loss, cleanup costs, energy savings, maintenance savings, health and safety, savings on equipment, automation and controlling the dust, and then return on investment. Briefly, dust tight versus dust controlled. The significant thing I want to mention here is dust tight. When I refer to that, it would mean no significant leakage of dust. When we talk about our smart conveyors later on, we don't have any industry ratings for tightness. Just they don't leak any significant amount of dust. There are some tiny little places things can creep out, but it's very, very minimal. Dust control would be situations of minimal leakage and minimal cleanup required. So we'll see a slide later that shows one of our mobile containers. And when they back up to the bin that they discharge into, you have to open the gate and there's a little material right there, but it's going to be an easy cleanup. So first, let's talk about material loss. When you're using belt conveyors, open belts, leaky conveyors, open piles of material, handling material with end loaders, and then you add in windy conditions, this can lead to material loss and large messes. Lost revenue. What's the value of your material? If you're talking $20 a ton and you lose a couple tons, that's really not a big deal. But if it's something that's going into your process to make a product like pellets or particle board, then those losses can add up. And when you're losing material, it's going somewhere, and that can create its own problems. Clean up on your own site or good neighbors. So you want to be a good neighbor. If you've got a bunch of material blowing across the road to your neighbors, you can get complaints that could lead to fines, possible litigation. We know of a customer that bought a large piece of land to the east of their mill of the complaints that came from the owner. So dust tight material handling systems, that would include storage, bins, conveyors, and virtually eliminate your material loss and also eliminate your cleanup costs. So clean sites, the gasifier project you see in the open-ended building, that's where the receiving and shipping and things like that are going on. So the mess is controlled there. Then it goes to a storage and feeding bin and comes through the conveyor to the gasifier, and you've got a clean process once you exit that building. So another example, if you see inside one of our conveyors, the mess is totally contained. On the outside, you see a clean conveyor. Same thing here. This is for an ethanol plant. They have a very dusty product in dried distillers grains from the ethanol process of grinding up the corn and getting the sugars out of it and such. And then you see a very clean area in and around the conveyor. An example of literally blowing in the wind. So in this situation, one of our bins does not have a containment feature on it. Actually, it does now, but when this picture was taken, it did not. So materials blowing all over the place on windy days. So they're creating a mess or losing material. The way to do this is to have receiving bins that lead directly into a conveyor, a dust tight conveyor. So here's what I spoke about earlier. You back up the container, you open the gate, you're probably going to lose a little bit of material right there before you get flush against the receiving bin. But once you start discharging into the receiving bin, everything's going to be nice and clean. Costs. So again, everyone's situation is different. How much does your plant, your mill spend on cleanup? That's something you need to figure out. When you're using belts, you're going to have messes when you're dealing with small particles. Um, so here you see leaky belt conveyors. You see carryover from belt conveyors. It's all common. It's all typical. It happens all the time, but it creates a mess that's got to be cleaned up. So dust tight conveyors can eliminate these types of messes, can eliminate costly cleanup crews. Think about HR. How much time does HR spend on hiring people to clean up your mill? And I imagine those people are going to be high turnover, which means HR is going to have to spend a significant amount of time. Cleanup crews cost you time. We're going to need supervision. It's increasingly difficult to find workers. I'm sure I don't need to tell you that. And the hourly rate of workers continues to rise. So one of our recent mill visits, they told us they were paying $18 an hour for weekend crews to come in and clean their mill. And they were having trouble finding people at $18 an hour. Energy savings is another consideration of dust tight conveying. So our smart conveyors are extremely efficient. Here you see a section view. We typically use 1/2 to 1/4 of the horsepower compared to other types of conveyors. And when we compare it to pneumatic conveying, more like 1/10 of the horsepower. The reason for this is we're very low friction, so very low horsepower. Our chains, you can see there, are supported in wear strips, UHMW strips, angle wear strips. It supports the chain for the entire length of the conveyor. Our paddles do not touch the floor or sidewall, not wearing out the paddles, wearing out the floors, or creating unnecessary friction, which would take more horsepower. So here's a project example, incline conveyors versus pneumatic. When we got this project, we were told by the owner that to blow material up into those truck bins was going to take 60 horsepower. This is several conveyors, but the conveyor that you see inclining up to the truck bin is using just 2 horsepower. We're 6 tons, which is a pretty small amount. It's our smallest conveyor, but it's only taking 2 horsepower to move that material up into the bin. So significant energy saving. Sorry, let me back up to that. You see, we're talking about dust tight conveying, and you see a very dusty site. Not in this picture. At the bottom of this picture, if we hadn't zoomed in so tight on the conveyor, you would see a cyclone that is leaking badly. And that's the reason it's snowing sawdust on this site, making all the mess. So talking about horsepower again, this is our calculations page for speccing out a conveyor. You see 6 tons per hour on the mass flow rate. We're moving at a pretty slow rate of 40 feet per minute with the chain. It's an 18-inch wide conveyor. Chain type is 81X, and we're at 40% of the working load. If you look down below the chart, you see conveyor capacity. Horsepower is 0.48, and then horsepower at 2.0. So we put a 2.2 horsepower motor on this conveyor, but this also shows that we're using our horsepower to move material, not overcome friction. So less than 1/2 a horsepower to turn the conveyor on and move it with no material. Maintenance savings. Our smart conveyors require less maintenance. We recommend a preventive maintenance inspection for 8 hours of runtime. Take about 15 minutes to do that. We also suggest a tension evaluation for the chain and possible adjustment after 2 hours of runtime, 200 hours of runtime, sorry. Replace curved wear surfaces once a year, at most probably twice a year. Um, Depends on the conditions, how fast the chain's running, the abrasiveness of the material, things like that. Great wear surface will last decades. On mill visits, we often see conveyors with patches upon patches um, due to due to the chain wearing out the floor of the conveyor because the chain is dragging on the floor. Our paddles do not drag on the floors, and we've never replaced a floor section due to friction across the floor. Safety. So no dust leaks from the conveyors, dust exposure claims from the conveyed materials. Safety, that's something that's difficult to calculate, but our conveyors have direct drives with no guards, less likely to have any injuries or workman compensation claims. Safer than conveyors with pulleys, drive chains, pinch points. Maintenance personnel are notorious for leaving guards off after they work on them, and when that happens, accidents happen. Noise pollution. Again, we're low friction. Our chains glide on those wear strips. Our conveyors are very quiet, so we have very little noise pollution. Um, Industrial sites like these are always noisy, so we're adding very little noise to that existing noise. Here's an example of dust-controlled trailer loading stations. So this is safer and less expensive than overhead truck bins, like you saw in the earlier slide. We know of cases where people have been killed by those bins opening and a large amount of material landing on them. The conveyor levels the load while it fills the trailer. Significantly less material loss when compared to a truck bin. They're not dust tight, but they are dust control. Here's a picture of one loading. Um, we have no floor in the bottom of these conveyors that run the length of the trailer. So when the pile gets up, the pile starts at one end of the trailer, and when it gets up to the bottom of the conveyor, the paddles come by and rake it back and level it off to fill the entire trailer. It's unless it's really windy, you're going to have the dust pretty well under control. Savings. Eliminate costly end loaders. Recent study by one of our customers, they estimated the cost to run an end loader for 1 year at $450,000. So that included fuel and labor and uh, all insurance and all the things that go into running an end loader at a wood processing facility. Eliminate repair costs for items damaged by the end loader operator. You know as well as I do, they always run into things. So there's damage created. Eliminate air permits. This is another possibility for you. If you can end pneumatic conveying, if you can eliminate it, you can get rid of your air permits or not need new air permits, which can be costly, time consuming, and a lot of work. The picture of the end loader in flames there. Anybody dry dust with loaders on a consistent basis, this is a common occurrence. This happens. Automation. Uh, Please consider the benefits of automation for the entire process, receiving, storage, handling, and distribution of products throughout your plant or mill. Again, everyone's situation is a little bit different. So for a sawmill, this doesn't necessarily totally apply. For a wood pellet mill, maybe it does. But think about it. You can unload incoming material into dust controlled bins. Then you can convey it in dust tight conveyors to storage. And you can have metered discharge from storage that can be segregated and have blending capabilities at discharge. And then you can have feed rates of boilers, pellet mills, and other processes. And if you have waste material that you've got to get rid of, you can load out without the danger and expense of overhead truck bins. All of that adds up to lower labor costs, be done without the use of end loaders, and cleanup needs can be eliminated. So go through that process, we're starting off with receiving. So dust controlled bins for material. So metered output from container picture to the use floor trailers in your process. Most people dump walking floor trailers on the ground, dump the material onto the ground or onto a concrete pad, scoop it up with an end loader, take it to the next step in the process. We can eliminate that end loader. Um, we can eliminate the mess that is created from unloading walking floors. So with this bin, you can back up the walking floor trailer right to the bin, discharge the material into the bin. It's got four screws, four gear motors, and it feeds a pit with a conveyor in it. You can see that on the right-hand side of the actual photograph on the right of your screen. So we can eliminate loaders from the process. You can eliminate the mess, and you can carry it on in a dust-tight conveyor to the next step in the process. So the next process might be storage. So here's some options to keep under control. You can feed and meter right out of these bins, eliminate open piles, eliminate loaders, eliminate the mess. To scale it up even bigger than the containers you saw, you can do a complete storage facility, a complete bunker or building. Again, it's dust controlled. All the dust is going to stay inside. You eliminate the open piles, the end loaders, and the cleanup issues. So this would be one of those containers. This would be the floor system inside that can meter the output of your material. Keep things under control as that happens. Here's another example. Here we're feeding into a centering bin to give a more accurate flow rate. This is the gasifier project that you saw early on. And you see no mess surrounding the container or bins or conveyors, and is carrying it on at a metered flow rate to the gasifier. Same thing if you're using a building. Here you have the floor system that can discharge the material at a metered rate. No end loader is needed. This is automated, so all the dust is contained within inside the building. On investment, again, situations differ, so you can kind of uh, evaluate your own situation, plug in your own numbers. Let's say a mill is using 10 employees on the weekend for 8 hours each day at $15 an hour to do just cleanup. That would be $8,000 a year at a cost of $120,000 a year. And that's just for those employees. It's not the HR process of hiring in, doesn't include supervision or anything like that. The return on investment, if you were to invest in $100,000 of conveyor that could clean up that mess and make those workers unnecessary, your payback would be less than a year. To get rid of 10 workers of cleanup, it'd probably take more conveyors, more investment, more material handling. But there you can see the different scenarios. $500,000 pays for itself in 4 years, and that's just over 4 years, and that's just counting the cleanup costs. It doesn't count material loss. It doesn't consider energy savings. It doesn't consider eliminating end loaders. It doesn't consider maintenance costs, health and safety, etc. So if we add in a couple more of those issues, let's go energy savings. Let's add in some energy savings. And I just picked an arbitrary number because I have no idea what your individual energy costs are, how much we might save. So let's just say we were able to switch from pneumatic conveying to dust tight smart conveyors and save you $15,000 a year in energy costs. You can eliminate one end loader. Maybe you eliminate two. Do the math. So $450,000 eliminated from your operation. Annual is 585,000. Return on investment, $1 million worth of dust tight material handling equipment would take less than 2 years to recapture that. So a significant return at a very quick rate. So in review, benefits of dust tight material handling. Dust tight can help you lower labor costs, equipment costs, energy costs, maintenance costs, can provide a cleaner, healthier, safer work environment. That's what I have for you today. If you have any questions, you can go to the uh, drop-down menu on your screen and look over to the right-hand side that says chat. And you can open up that window. And if you'd like to ask any questions, feel free to type one in and I can answer them for the group. If you do not have questions but want to talk personally, you feel free to call or email me for more information. My contact information is listed there. So we'll hang around here for a minute, see if anyone's got a question. I want to thank you for joining us today. Hopefully we helped you think things differently or just brought some things to your attention to think about that might help your operations in the future. So if you have any projects in the future, please contact me. We'd be happy to put together a budget quote for you. We look forward to working with you. If any of you are ever in the Indianapolis area, please contact me and we can arrange a visit for you to come and see our factories.